Welcome to this short presentation about the statistical analysis and conformity criteria for compressive strength. Reference to ACI 214. So in this example, I use C50 triple blend mix, and as you can see from this table, from November 2022 of casting date up to June 2023, all throughout these months, it is self-explanatory to look at this figure showing that specified strength C50 in this blue color, and as you can see above this one are the two lines, the test average and the average of 3 consecutive strength tests, which simply means we are exceeding the specified, means pass, and almost straight line was being formed. So there is really consistency during those period. So this is the first table, very simple but informative, and you can easily judge the degree of control being done in this plant. So moving forward, I use the second table for the assessment of coefficient of variation, and the third one is the assessment for within test coefficient of variation. I will explain later, but let us go through the definition first based on ACI 214. So these two things has to be very clear to the user. First of all, the individual strength. This is a single cylinder strength is part, but individually does not constitute a test result. So meaning to say, if you have 30 pieces of cylinder, it doesn't mean you have 30 strength tests. So there should be like average of 2 to 3 individual cylinder, and the average of that will be equate to 1 strength test. Again, as defined, average of strength of 2 or more single cylinder tested at the same age. So by doing an average of these 3, in this example I have 3 specimens, only then you can say you have 1 strength test. So I want to show you this table 3.1, where is the principal source of strength variation is coming from. This is a good table to show whenever you have dispute or some technical query about the variability of your strength. That's why I wanted to share to you, because simultaneously when you are monitoring this table, the reason why you are monitoring this is to catch immediately the variability from where it came from, either from the overall coefficient of variation, which is more on the raw materials, the condition, machineries, whereas the within test variation normally comes from the workmanship of the technician, like sampling, curing, transportation, consolidation, etc. So whenever you have bad within test coefficient of variation, means something is wrong with the technician itself, down to the laboratory where maybe it's not properly cured. So this is the table 4.4, where we are referring to this overall coefficient of variation and within batch variation. And ACI actually recommends to use coefficient of variation whenever you are using or whenever you are having 35 strength and above. So below 35, you have to use standard deviation for the controls assessment. So in this example, I use 30 strength tests. This is the best, you can have the best presentation whenever you have 30 strength tests, and that's why in standard deviation you don't need any factor. Some specification calls for 40, even ACI, it recommends also 15, but in that case you have to use the factor, like 16% you have to increase your standard deviation. And whenever you have more sample, it's better to use the 30 strand test. This is an open formula. When you use this template, you will see the formula, and simultaneously you can double check from the book. Also, I attached some tables here in this worksheet for a quick reference. So whenever you feel that you have doubt, you can immediately look at these tables which I attach on this template. And you can always double check whenever you see these lines. When you put the cursor where the formula is, it will highlight. So make sure that it is in proper place so that you will have these tables in place as well. You can see this line showing, so you have to maintain. So that's all for today for this short presentation, and you can message me for any query. If you have any doubt, you can send me email to request a copy of this template, which is very useful